Hey there, folks. My name is Lucas Martin. I'm our business development manager here at ARC Advisory Group. Our analysts make it a priority to monitor the key technology changes, vertical industries, and any regional trends impacting the global business environment as a whole. This is a new market update segment where I'll pick the minds of our industry experts here at ARC Advisory Group. We'll chat about the scope of the market, the supplier landscape, key growth and success factors, and any key trends they may have discovered through their research. Now, let's not waste any more of your time and hop right into the interview. Hey there, folks, and welcome back to another market update episode. Today, I'm joined by Rick Riss, a senior analyst here at ARC Advisory Group. Rick recently finished a 2023 global market analysis report on microgrid automation systems, and we wanted to set up some time to share a little bit more with the audience. Thanks a lot for the time today, Rick. Can you just overall explain the scope of this market analysis report, maybe how we define this particular market segment?
Sure. So microgrid automation is actually a subset of another ARC report, which is called all grid automation. And it's probably about 15% the size of the entire grid. And we define, the hardware for microgrids includes the inverters, rectifiers, battery chargers, relays, reclosers, switch gear, circuit protection, power meetings, SCADA, all the switching and communications, all right? But we exclude video surveillance, grid step-up transformers, HVAC, building automation, and we also exclude all of the generation equipment. So no wind turbines, diesel generators, or solar panels, all right? And so we do try to focus on all of the various software and automation sectors. So I think that kind of gives you a rough idea. We also limit the size of the grid to roughly 100 megawatts maximum, and we try to keep it up above, out of the residential level. So it's going to have to be a little over 20 kilowatts of size at the lower end. But okay, we try to capture all the commercial and and even pretty good sized microgrids. A larger microgrid might be a college, campus, university, for example.
Okay, Rick. Well, hey, thanks a lot for the clear definition there. So, can you give the audience an idea of the overall supplier landscape in this market?
Sure. So, a lot of the suppliers, in terms of revenue levels, are coming into the electrical, switchgear, recloser, and protection area. So you'll see a lot of suppliers like SCL, S&C, Siemens, GE, Schneider Electric that are providing that physical equipment. All right. Then there's also kind of another level of after the protection level, all right, which is the primary control relays, safety relays. There's kind of a secondary level of local management and control of all the distributed energy storage and loads, all right? And then finally, there could be a tertiary level, which is kind of the remote connection to the grid, the controls, the optimization, load forecasting. Microgrids often have to figure out, well, when am I going to charge my battery? All right, if you have a battery. And, if you charge your battery too soon or too late, depends on what markets you are participating in. So we kind of have a primary, secondary, and tertiary level of control that comes from safety to local management up to the grid interconnect.
Certainly. So, Rick, while you were doing the research for this report, can you maybe explain or describe a key growth or a success factor you might have uncovered, or maybe a couple?
Yeah. So one of the big drivers for microgrids is people really have become very dependent on this electricity stuff. All right. And, when their electricity fails, they lose a lot of money. And so one of the things you'd find, for example, is if you were in PG&E territory out in Oregon and Northern California, and all of a sudden they decided they're going to shut your electric power off for, say, 2 weeks to avoid wildfires, and you're running a gas station, a restaurant, or, some other type of business, you're going to get a generator, all right? So you started with a diesel generator. And then you start realizing, well, I got to run that generator for weeks at a time. Then maybe you said, well, I'm going to put some solar panels in a battery. And as soon as you do that, you basically have a microgrid, all right? You can operate autonomously, independent of the grid. So when the grid goes down, you have backup power. In some cases, you can even make a very smooth transition from when power fails to, bumplessly, switching over to your backup. That's especially true with batteries that don't take a longer time to start. Diesels often take a few minutes to get up and running. And then, of course, when the grid, now that you have batteries and solar panels and things, you can participate with the utility that when you are connected to the grid, maybe you decide when to charge your batteries. Maybe you want to discharge power from your batteries, or even in some cases from the diesel generator when there are peak load events and the grid is desperately needing, more power. And we're going to see this type of volatility more in the future. So
great. So let me flip that one on you, Rick. Did you maybe uncover a growth inhibiting factor you wanted to share today?
Well, one of the big growth inhibiting factors is actually trying to be solved by the new FERC 2023 order that came out this past August. And what it amounts to is that there's a huge interconnection queue of all kinds of renewable energy, particularly solar panels, especially, waiting to get connected to the grid. And a lot of the utilities, the ISOs and RTOs, that's the independent system operators and regional transmission operators that are put these potential projects into a queue saying, well, we're not quite sure we want you to connect to the grid just yet because, all this renewable power, we're not quite sure how to manage it all. There's going to be, non-dispatchable intermittent power. And so they put a lot of this, a huge amount of projects out into this interconnection queue, and the FERC, and so that interconnection queue prevents these new projects to come online. And, obviously if it's solar panels and a battery, that's effectively a microgrid. So that's slowing down the development of microgrids, at least here in the US, this is the case. The FERC 2023 is attempting to open those floodgates. It's a little too early to see just how effective that's going to be, but there's a significant possibility that one way or another, all these renewable energy sources are going to get connected to the grid, and the grid operators are going to have to figure out if they need new transmission lines or new distribution or new market structures so that they can put all this new renewable power onto the grid and minimize the amount of curtailment of carbon-free power.
It's really fascinating figuring out how, some of these new legislative, bills are really going to affect the market. So interested to see how that one plays out, Rick. So let me kind of pivot the conversation a little bit. Let's say I'm an end user, I'm an asset owner looking to purchase a system like this. Do you have any strategies you recommend to those folks?
Yeah. So, a lot of people think, well, microgrids, they're all going to be built by the electric utilities, the NSTAR, National Grid, PG&E, Southern Company, all of the bigger, grid transmission and distribution operators. But it turns out that a lot of the developers are, can be private entities. You see a lot of municipal groups putting together, say, well, we're gonna put solar panels on our school. We already had a diesel generator. We're gonna put solar panels in a battery, and then all of a sudden the school becomes a place of refuge if there's some natural disaster, and it has a diesel generator and it has solar panels with a battery. We see, obviously college campuses have a physical plant, and they are better positioned to put more sophisticated integration of building management, heating systems, and electric power distribution, and of course would like to have the image of making that power from renewable, non-carbon emitting sources. So we see a lot of universities. Obviously, there's the military that just insists on having reliable power and wants to be independent of the grid if they need to be. And in some cases, the military has mobile microgrids that can move around. We also allow in our study, to some extent, little islands, physical islands that you might see. You see a lot of islands out in Indonesia and Philippines, for example. And the island doesn't really have power. It's technically not a microgrid in the sense that it connects to a larger grid and disconnects, but it's very much equivalent to being a very small, independently operated grid. So it's basically a microgrid that always operates in island mode. So we see this wide variety of different places where where microgrids happen. And we see a lot of rural electrical co-ops, municipal electric departments, deciding that they want to provide backup power for their community, their town, especially in rural locations, where electric power is less reliable. And it's not always the utilities and bigger grid operators that are putting microgrids in.
Interesting. So, Rick, I know we're running short on time here. Was there any other key trends or points you wanted to share with the audience today before we wrap up?
Yeah, I think that one of the things I know I wrote a recent blog report on this is that if you really just look at the economics of microgrids, the cost of solar and batteries have come down remarkably. So this is a big impact that might make microgrids more possible. And a lot of people didn't even think they necessarily had a microgrid. They put a solar field in and then decided to add the battery later, right? And so you definitely will see, trends moving that way. And the third thing, of course, is that rural communities suddenly say, they got cell phones and refrigerators. They want reliable power. There's a lot of, people might have medical equipment like an oxygen maker that just must work. And as a result, they're going to put in backup power. And the cost of losing power to both industry, commercial, and residential levels, the cost of losing that power is very, very significant. I'm in a home office. If I lost power, suddenly I'm not connected to the office anymore. So maybe I want to have, solar panels on the roof and batteries in the garage. Those are kind of nano grids, but at the community level, they want to provide that support and improve the reliability of power. And there's a big payout for staying reliable.
Absolutely. Absolutely. Well, thanks again for the time today, Rick. As a reminder to the audience, we have links to our website and more information about this market report in the description below. We'd love to talk about how market data, analysis, selection guides, and overall reports like this can help out your company. So thanks again for watching, and we'll hope to see you on the next episode. If you like what you saw in this video and want more informative content, be sure to like, comment, and hit the notification bell below. Also, if you haven't already, please be sure to subscribe to our YouTube channel. Thanks again, folks. We really appreciate the time, and we'll see you in the next video.